Hello, my friends, and welcome to this episode of the AI Show. Happy Friday. I'm super excited to be here. We've got a cool show today. We have some people that are staying up late to show us some goodness. So welcome. We have 2 hours chock full of excitement, greatness, and all around good time. Actually, for the first half, we're going to be looking at a cool project that won the OpenCV 2022 Hackathon People's Choice Award. OpenCV People's Choice Awards. I know, it sounds cool, right? And then after that, we're going to dust off our Roshambo project, which has been neglected. It's true. All right, so let me share my screen and let's talk about our pandemic purchase. Let me share my screen here. Boop. 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 My guess, I keep putting them in. They're here, but I don't want to tell you who they are quite yet. All right, so today, in number one, OpenCV. Let me move this over. People's Choice Awards. It's cool stuff. I talked to them yesterday or the day before. They have a really cool project. And the good part about it is everything is open source. You can take a look at it and play with it today. Even. Number two, I thought I would share just for a second our build demos. And by share, I mean like our repos. So you can go look at the code, ask a question. And then number three, rounding out the end of the show, we are going to go back to Roshambo. Roshambo Rock. I don't even know if it works anymore. So this might be like, oh, I can't spell scissors. So this might be like a super interesting like exercise in revisiting an old project. You know? Where you're like, wow, that was high-pitched. All right, where's everybody coming from? Let's take a look. Hello, Janice Q number 7. Janice Q number 7! Coming to us from Le Twitch. Can I just give you a round of applause for this pun here? It is a sight to behold. Friday, I mean, this is just, this should be in the Louvre. Like next to the Mona Lisa, this picture of Janice Q number 7. Friday. It's, again, I thought I had the definitive book here on no. I needed to throw this out. It's been thrown out. I just can't top it. Hi there, my friend. Welcome to this episode of the AI Show. Good to have you. Yes. Brought to you by Seth Ward. I should be like a used car salesman, I think. Lowest prices on the lot. I don't know. Good morning, Phil. How are you, my friend? It's good to have you here. Who else we got? I'm trying to see this. Is Sugata? Welcome. Go back to my full screen here. What are y'all telling me? Good morning. Do the show in the morning because half the world is sleeping in India now. Yes, Sugata, I will tell you, I'm probably a little bit asleep myself. You know? Good morning. Forza B-AROL-O. Yeah, I'm excited. Gianluca, look, he's one of our cool guests. Don't tell him. Yes, please. I like 11 a.m. Jay McCormick. You know, Jay lives in the same place I do. We don't hang out. Never calls. Just something I said.
I'm not a robot. Okay, I'm a human that has feelings.
Even if it doesn't sound like it. That's my inner AI came out. All right, friends, welcome again. We're going to do those three things. But first, let me bring up Team B-AROL-O. Boom. Hello, my friends. You're on mute. Can you unmute yourselves?
Hello.
Hi.
And you may think they have cool accents, and they do. It's because they're from Italy.
Yes.
How are y'all doing? What time is it over there?
It's 8 o'clock p.m. 10 after.
Oh, I'm so sad. Like I told them the other day, I was like, friends, we could have recorded this before, but instead they're dedicating their Friday night.
Yes.
This is a good choice.
You say that now. We shall see. All right, so let me get my notes up. For those that don't watch the show, so sometimes what we do is I work for Microsoft, and we build an actual official AI show that we record stuff, and then we put it out, and it's all profesh, not anything like this. And so what we're going to do is we're going to enter into the professional version of it, and you're going to see us like record the show. I edit it after just this little slot afterwards. And so you're the live studio audience. And friends, you said Gianpaolo, Alessandro, and Gianluca, you said you would stay after to answer questions. Is that right? You still okay with that?
Of course. Absolutely. Until tomorrow.
Oh, man. Oh, what can I say? All right. So what we're going to do is we're going to get started on this AI show. I usually turn it, so there's like background music. You can hear it. Oh, it's kind of off right now. I have it on loop on channel 3, if you were wondering. There it is. And so I turn that stuff down during the professional part. Okay. All right, friends, just a couple of tips. I'm gonna ask you questions. I think we decided who's gonna answer which questions. If you run out of things to say, stop talking. Try to look at the camera the whole time, unless you're looking at like your code or something. I think that's it. Let me make sure that I have your screen ready. Yes. Look at that beautiful screen. I love it. So everything's ready to go. All right, let's do this. You ready?
Yeah. Yes.
All righty. You're not going to want to miss this episode of the AI show where we talk to the 2022 OpenCV Hackathon winners, Team B-AROL-O and the ARNEIS project on the AI show. Make sure you tune in.
Yes.
Hello and welcome to this episode of the AI show where we're talking to Team B-AROL-O and the ARNEIS project, the 2022 OpenCV Hackathon winners. Friends, let's start with an introduction of each of y'all. Gianpaolo, why don't we start with you?
Yeah. So hello, everybody. My name is Gianpaolo, and here with me,
Alessandro
and Gianluca. So basically, we are 3 friends who happen to work in the same place. And the company where we work in is B-AROL, who kindly hosted us in their offices late in the evening to give this short presentation of the project we have been involved. So a quick story. In November 2021, we learned about this OpenCV Special AI contest in 2 days before the deadline for submitting a proposal. And so we rushed and we said, oh, there are so many beautiful prizes, like hundreds of dollars in Azure cloud services, a smart camera like this one we will show later, and especially Legos. So we had the way for having fun paid, and we say, why not? So we submitted a proposal, and the proposal came with the request of a name of a team.
Okay.
And since we are working in B-AROL, guess what? Our team is called B-AROL-O, which is also a name of a wine, Barolo, a red wine that is made in Italy, in northern Italy, in Piemonte, where we live. So we are here in Torino, in northern Italy, and that's why we chose this name. So the choice of the name was easy, and then it came to the project. So what we could do And the request was to develop a industrial machine based on AI. So AROL is making cutting machines for the bottling industry.
Okay.
So again, the choice of the name of a wine was not coincidental, and also the name of the project is called ARNEIS.
That's really cool. And so it's just a
Another
bunch of
white
friends?
wine.
Y'all were
Yes.
just a bunch of friends that got together?
Yes, only for having fun and trying to learn something, because we did not know nearly anything about AI and computer vision. So we took the chance of learning if our proposal was accepted. And actually it was, in spite of our expectation. So what we did was to start learning and trying to make a project. And the project of ARNEIS is also an acronym of automated. I should read because I cannot remember on top of my head. But the acronym is for Automated Recognizer Network Enabled Item Sorter.
Oh.
So what the project will do is taking bottles. We took small bottles because we had a small Lego set.
Sure.
And put on a machine that we will show, and using this camera, recognize bottles just by looking at the shape. There is no barcode. They are all the minion bottles. And the machine is sorting and dispatching depending on the job order that has been submitted through the internet. So this is basically, in a nutshell, what we have done. And
didn't you brought a video though to show us like where you live and what you do, right?
Yes, exactly. Because I mean, everything came out of coincidence, but probably we put internally inside this project most of the excitement and the experience we have been doing in the company. So can we have a look at the video set?
Let's do that right now.
Great.
Well, that was delightful. So let me see if I understand the project. Basically, you use AI to help fulfill orders of bottles of wine. Am I getting this right?
Yes.
Exactly.
That is really cool. So I want to ask you a question. Because I think this is important. I saw that you used a little camera. I saw that it was actually Legos. You weren't kidding about Legos. Can you tell us a little bit more about the project? Can you help us out with that, Alessandro?
Yes. Okay. As you know, there is a lot of things to do in the project. My job was to play with Lego. I'm sorry, build and design Lego projects.
That's awesome.
So, and the better way to show you my work is to share our public site,
Okay.
where we put all the information. You see our public site, and in the public site there is the first part of the Lego that I had to study, and is the mechanical adapter for the camera. So I have to create a mechanical adapter that has that was light and simple, and using only pieces that come from the Lego set we choose to use. And so the idea is to have a frame that is used to fast assembling and disassembling the camera, and also to leave the access to the USB port, and don't cover the back part of the camera that is used as a surface for dissipation of the heating. The next big task was to do the conveyor for the bottles. So that was a little different and more difficult part, because Lego pieces doesn't, there is not a Lego parts that can be used as a horizontal conveyor.
Right.
So I have to study a different way of move bottles. So I put a belt, a mechanical belt with some arm that push bottles on over a flat surface. As you can see in this way, there is some first tries, and this is the first try that I made to do this job. After that, I need to put some motors to move this conveyor, and you see is, for example, this conveyor motorized, and I need also to create a background for the camera, for the bottles to be shown on the camera. As you can see, there is a part with the camera, what you see. This was the first part. After that, there is the real project of the system that comes, and there is something about this. You will find all the information, all the project, the CAD project, and also building instruction for all these pieces in this site.
Yeah, and let me put it up so people can see it. It's right, arneis.readthedocs.io. It's very, very thorough. That's really clever. I noticed this, and it probably went by really fast. That's really clever that you put a consistent background for the bottles for the AI to recognize them. Did you do that beforehand, or did you discover that while you were building the model?
No, we started in this way because we thought that having a background is better to select or to see the real neck and body of the bottles.
And by the way, we had the white pieces, which was quite luck for us, because I said the pieces we could use were limited by the set that we had for the project.
So it all worked out in the end for y'all. Now, I have a question, and maybe the answer is no, but do you have the actual device with you to show us?
Oh, yes, sure.
One part of it, at least, we could put on the table, but just have a look.
Let's take a look here. I'll put you on full. That's really cool.
And this is, you see something is, this is the camera.
Uh-huh.
And
Here is the bottle.
here's the bottle. And here,
And the battery got flat, sorry about that.
the white part with bottle that way. This is the expulsion system. And, but okay, you will see in the project if you want.
And if you happen to have the set and you follow the instruction, you can reproduce the design at your home.
That is so cool. I mean, I'm trying to picture myself telling my significant other, my partner, hey, I need to buy like a really expensive Lego set, but for work.
Oh, yes.
It's for this is all for work.
This is what I say to my
Did you understand our motivation?
My wife.
The price came just before Christmas, so we had free Legos for Christmas, or
That
just
is-
later.
That is fantastic. Okay, so Gianluca, you kind of been sitting there a little bit. I wanted to ask you, hopefully you know the answer to this. Can you tell us a little bit more about the software? Because the hardware stuff was super interesting. I love the details of the project. Can you get into the software, Gianluca?
Yeah, as mentioned, we should start thinking that we didn't have any prior experience on computer vision and AI. So we started with a simple task: learn the capability of the OpenCV framework and see if it could fit our needs. We began by watching an OpenCV free 3-hour course, which gave us a lot of key information about the framework itself and image and video manipulation. Then, as soon as we received the Oak Delight, thanks to Luxonis, we discovered the .ai framework and started to learn how to use it. With that, together with the basic knowledge from my university studies, we started to develop a basic software that could recognize potentially minion bottles. Then came the other part of the software, which was the training of the neural network. I know many of the people connected already know this part, but to train a model, pre-existing one or not, you have to have a lot of data. In this case, the data are images, which have to be labeled to tell the model which object it is seeing. This process is probably the one that takes the most time, which can be, in our case, it was more than the training itself. After some tests, we decided to use a RoboFlow for this procedure. And you can even run the trained model for inference on there. At first, the training was made on my computer with a few images. And as soon as we add more data and so more images and more confidence with Microsoft Azure, we moved the whole process there. For the final training, we used like 1,000 images, thanks to RoboFlow Magics. And every step along the way came with a series of tests, which we shared weekly with the community. And some of these you have already seen in the video, which we submitted. And we are still looking at some of the inputs we received, for example, from Satya Malik. We are still working on it, trying to improve it.
That's really cool. So I know when we talk about like hackathons, old school, we would all just show up at a place and code for like 24 hours or 48 hours or something like that. This wasn't like this. Can you tell us how long this took? Because you mentioned you talk to community once a week and stuff. Tell me about the whole process there. Why don't we give that to you, Gianpaolo?
Yeah, I mean, as said, the submission came in late November. And then the award for proceeding for the final was starting in December or so. And we had nearly 3 months for the development. In spite of other teams that started from something we had already, we started completely from scratch. So we had a lot of things to do. And we put kind of a project like we do in our real job. We put a project on GitHub, we had an issue tracker, and used this weekly milestone to have a motivation, have a target for our goal. So we decided at the beginning of the sprint what to achieve, and we tried to respect our schedule. Sometimes it was easy, sometimes it was not. But the motivation was to communicate every week through a blog post on the community what we had done and possibly which were our roadblocks. And we received a good feedback thanks to that, and also some motivation to continue because other teams were selected and did not submit at the end. We did, and thanks to that, we won this popular vote. So probably both things were instrumental for us to achieve the goal and also to be here tonight.
That's cool. And so basically along the way, you posted your wins and losses or how things were going on a blog post, and people just started to participate. Is that right?
Yeah, we also received comments, issues, and pull requests on GitHub, our project, by external contributors. Then they became friends, and some we are currently working with us in our job. But they started just by looking at what we have been doing and also trying to give some help. The same logos, the ARNEIS logo that we have in our T-shirts and the B-AROL-O logo were made by a student. Then we just happened to be nearby, and now we are in close contact with them.
That's amazing.
I said, all the code is there, and it's free to use. If you find something useful, use it and possibly improve it. In our company, we are also, I should mention that AROL was not involved at the beginning. We decided to do the job as part of our self-learning curve in our spare time. We didn't even wanted to tell the company that we were doing that, but they discovered because it became public, and to our surprise, they were supportive. So they liked the joke we made on AROL. AROL is a trademark, but they say, oh, that's fine, just use it. Of course, respecting the, so sure. This is a private work, but it's public. And by the way, you did some wonderful job with such smart camera and OpenCV. Maybe we can consider in doing some work or some project starting on that. So I cannot exclude we will do something commercial. Probably will not release everything in the community. I see. But what we can, as much as we can, we will share, and we will continue the project on GitHub.
That is,
so have a look and help us.
So people, you want people to get involved. Where can people get involved? Where can they find out more? Just to finish up.
Yeah, I will point you out to the homepage on Read the Docs. So ARNEIS Read the Docs, as you've shown, where you can find pointers to the GitHub project with the issue tracker. And also we have a Twitter feed that we are using for communicating, giving news and events. Okay. But just follow the GitHub, and it's easier to know how it works. And of course, also submit pull requests. We are more than glad to do that.
Fantastic. Well, this has been delightful. Thank you so much for being with us, my friends.
Thank you.
Yeah.
All right, friends, you've been learning all about the 2022 OpenCV Hackathon winners, Team B-AROL-O and the ARNEIS project here on the AI Show. Thank you so much for watching, and hopefully we'll see you next time. Take care. That was so cool, my friends. All right, so let's see if people had questions or comments here. I'm gonna bring my thing over here because my eyes are not. Someone, Fabio Pregno says, "Bravi ragazzi."
Our friend.
What does that mean?
It's a good fellow. Good job. Yeah.
Good job.
Honestly, he's a colleague of us, but he's a real mechanical engineer. We are all automation and software engineers. So hopefully we did not violate any trade secret, because we don't know any secrets on the mechanical. So stay sure that our machines are not made with Lego.
So the real question is, did I say it correctly?
Yeah.
Bravo ragazzi. Is that the way you say it?
Perfect. Good job.
Well, now you all have to accept me into your country. That's so. Here's a question. By the way, from Janice number 7. Very cool, minimal design. He loves that. Here's the question from Jay McCormick. Are those custom built Legos or just regular off the shelf Legos?
As said, all the parts came from an actual Lego set. You can find the details on Read the Docs. Okay. It's the excavator, the Liber, I don't remember the exact part name, but if you show the video from, okay, this is the Lego set. We used more than half of the parts, and especially all the motors and the controllers. So we chose the set because of the automation part that were part of the set.
I have to go buy it now. It's important for me to have this.
But there is a risk because this set went out of production during the project. So this was part of the risk we had to manage because it was really hard to get hold of one set during the time. So we started designing on the CAD, and Alessandro did a good job on the mechanical 3D model. And then we had trouble to find the actual parts. But eventually we got one, and this is what we shown. So if you find one, just be jealous of it.
I need to, man, this is all worth it if we can just use this Lego bits right here. So this is awesome. So that's all the questions from the folks that are watching. By the way, this is a fantastic idea. It's delightful to be with you. I mean, I think the cool thing for me is that you got to learn a ton of stuff. You got to play with Legos, and then your company was like, whoa, this is so cool. We love you. This is awesome.
Oh, of course, they didn't give any money. Only the contest gave us money and allowance, but the company just said, take the room for the webinar, and it's fine. So we did not ask, they don't give.
That's so nice. Well, thank you for being with us, my friends, and hopefully you can catch us up maybe sometime later.
Yeah, no problem.
Thank you.
See you later. That was cool. That was really cool. Like, I want to go find this Lego excavator thing. Like, I'm gonna go. Let me bring up my screen here, and let's see if we can't find this Lego excavator thing. Hold on. There we go. So it was. Let's see. It was ARNEIS. Let me bring the link up here because I actually have it. ARNEIS readthedocs.io. So ARNEIS.readthedocs.io. Okay, this is it. Here we go. All right, so there's Lego. Okay. Do they have this, and how much does it cost? Here we go. We're looking. Okay, don't let me down, internet. Okay. The Liber R. Liber R 900. Come on. Yeah, I was in the middle of something, Lego, and now, like, I have to, okay. Okay. Liber R 9800 excavator. Oh, man. Do you see this here? Retired product. I mean, what is this? Lego? Is there like a also whoa. Why is my internet so slow today? I can't download anything. Let me do a speed test here. Speed test. Start. Here we go. No, it says I'm at 250 down. Oh, my up speed is it's at 30. Let me refresh. Oh, jeez. Come on, Lego. Uh-oh. Am I going out in and out? How embarrassing. Okay. Dang it. 1 second here. I'm thinking I might be having internet problems here. So let me do this. No, it says it's good. Can y'all hear me? Everyone okay? Everyone can hear me? Let me see, because people would tell me on Teams if I'm having an issue. Oh, there you go. I guess I had like a little hiccup there. Hold on, what's this thing telling me? It says my connection is unstable. Psh. Okay, here we go. So maybe there's some other ones that, oh, look at this. This one's available now. This is me right now because I don't have it. Very sad. Very sad. But this might be the one that we can make something out of this. So they basically took the Lego things. Why is my internet so junky today? Okay. Okay. All right. Well, there you go. Okay. So I wanted to show you two GitHub projects here. And if you didn't watch this, if you Google with Bing into focus AI, you'll see there was this Microsoft built into focus AI. This is our session, me and Eric Boyd, and a bunch of other people. But I should have had them put more people in here. But you can see that there is. Download the video, download the transcript. We actually built something. You can't hear this, but that's okay. We actually built an app, and I know I showed it to you last time. Well, I showed you the video. But if you go to GitHub.com and go to let me show you the actual. There's this aka.ms build Azure AI. You can just go there. And you can see here's our keynote and stuff. We put this together, some additional resources, but the actual repo of all the code is there. Wow, someone put all this stuff in there. That was probably Aishigal because she's awesome. You can actually create this particular app yourself, and in theory, you should be able to provision the entire project and have it up and running yourself. And the code's all here. If there's issues, just put them in there. We're trying to monitor that so that it works. But you can see it's got actual code and some back end services that you got to put. It's all in there. So that's this one. And then the second one, the one that I spent the most time in, is here. Let me Control Plus this because it's tiny. You can see the actual AI stuff that we built. So, for example, the train IPYNB, the model IPYNB, you can see there's some components in there that we built, like let's see, a fine tune one that like fine tunes GPT-2. So that's all there, and you can totally just play with it. In theory, I mean, it should work. If there's any issues, again, let me know. I've actually gone through and it's authenticating me. It knows me. There aren't any open, but there's a couple of them that I closed. Like, for example, there was there was something that needed to be changed, and so I went in. I'm going in there and fixing things. Right, and so this was another one that was an error, and that was because how did I fix it? Oh yeah, there was an issue with the thing, and so notice that was in there, and there was some that I actually had to change some code. Did I? Yeah, I actually had to fix with some code, and so go in there, try it out. This is a fine tune of the GPT-2 model. So there you go. All right, it's time, my friends. It's time to get to work. Time to get to work. Now I don't even remember how any of this stuff works. So here is our Roshambo project. Control plus. I don't even know if it works anymore, ladies and gentlemen. Here's our AI. I think here's our trainer. Yeah, I'm starting to remember some of this. MLflow log params. What does this do? I don't even know what any of this does. Oh, I know what this does. We have a test image. We have a score. Let's look at the web. Let's see what the README says. Yarn dev. Let's open up the. I wonder if there's like a. Yeah, it looks like there's a Conda environment that we're using. Let's see here. Settings. Is this not needed anymore? Nope. Okay. So we've got our Docker file. Let's run this. No, I don't want that. I don't. Okay. All right. So let's go to the actual, and this is going to be a dumpster fire. So let's see if it works here. ls, and let's say yarn dev. Oh, okay. It seems to be working. Let's go over to our browser. Here it is. We want to do this one. I don't even remember. It's like, how is it even supposed to predict stuff? Wow, this looks really nice though. Look at, it's got like a cool icon and stuff. Like that's literally a paper and a rock. We were super clever. So the idea is we're building a rock, paper, scissors. And I put my hand out and it's supposed to just, see it. And I'm playing against the computer. So that's what I'm doing. And I built a model to do that. But I don't remember. Let me pull this banner out. I don't remember how it actually sends a thing. So let's go to. I'm gonna go to the secret version of Azure ML. Don't tell anybody. Don't tell anybody. Let's go to our endpoints here because I think I made an endpoint for this. There it is. I think it's Roxy endpoint. Well, let's test it. Let's see how I tested it here. Go to our AI. I'm just still trying to figure out like what I even did anymore. Okay. I think this is the right one. Maybe I undeployed it or something. Maybe I need to deploy it again. Let's go to cloud here. Let's go to deployment. This might even be old too. I think this is old. This is not even the way we deploy it anymore. We might have to redeploy this, friends. Holy cow, this is so old. Like the code changed. We don't do this anymore. Oh. Well, looks like we need to fix our AI real quick. Otherwise, we can use... where are you? Where are you? No, not here. Where is it? Not this one. I have too many browser windows open, so we'll close that one. Not this one. Here. I think this one works. We can use this one for now. So we can either fix our AI, because in theory what this is supposed to do is it's supposed to make it so that it automatically knows like what the inputs are supposed to look like. Unless it's changed since we did it. So let me give it this thing, see if it gets the right answer. Yeah, so it looks like it loaded a ResNet. Y'all are the best ever. Keep working hard. Yeah, of course you can contact me about this. Okay. So image. Okay. Does. Let's see if it does it. So I think that's what the code does. Let's take a look here. So basically what it does is it runs the URI. The URI here gets an image, right? Because that's the thing that comes in. The output has these things, which is great. So the image comes in. If it starts with an HTTP, we pull it with requests, get the bytes, convert those bytes with a transform. Let's go to definition here. Where's the just define? Go to definition. Why can't I do that? There it is. And there it is. So it takes the image, resizes it, centers it, 224, does a normalization. Okay. Gosh, it's like I'm spelunking in code I wrote 50 million years ago. There it is. Transform. Oh, looks like I'm using the Onyx. It runs. Go to definition. Oh, wow. Why isn't it letting me do any of this stuff? Oh, probably because it's debugging or running. What is this? Terminal. Oh, maybe because this is going on. I mean, I feel like I should see more stuff. Okay. So this runs the pulls out the first. Oh, I see. So because, yeah. So this thing. So the image that comes in is basically this like 3D tensor, right? It normalizes it. It normalizes it, squeezes it to 224, 224 by 224. You know what I'm saying? But because of the way this thing was trained, it gets a batch of these. And so there's a fourth dimension that has like the number of samples. So N, right? And so when I get the image, right, it's going to be 224 by 224 by 3 because of the channels. And what I need to do is an unsqueeze basically puts a 1 in front of it so that it says it's a batch of 1. That's what's going on there. For those that are wondering. And then for the predictions, it just goes through each of the predictions and the classes. Where are the classes coming from here? Oh, here they go. Oh, yeah. There's that model metadata. Is our model even here? Yeah, there it is. So there's our model metadata. This is where it gets this thing. Looks like it's this one's a VGG 19. It has how many parameters? Let's see. 243 million parameters. Interesting. And then there's the Onyx file. Let's reveal this in File Explorer. And let's open this bad boy up. Let's see what we got. Oh, snap. That looks weird. Why does this look so weird? What happened to Netron? What's going on? Edit. Do I have the latest version about Netron? Lutz. Help me. He emailed me one time and I was like, Lutz. I'm such a fan. I don't know why this doesn't have like, this should open. This should look nicer than this. Because this is a lot. The VGG 19 should be bigger than this. But anyways, that's that. So that's where that comes from. So let's go back to the score. Once it does that, it fills out the predictions. And then the argmax, obviously, is the predicted class. So let's go over here and see if it did it. Oh, that's not good. The upstream container died. It's like it needs to wake up. No, is it still? Did I just test it and it got mad at me? Let me go to. Let's go to the monitoring here. Yeah, it's just not, it's like not on. Let's see, 100% here. No, I don't want to do this. Refresh. This is what happens, friends, when you don't do something for a long time. Let me control plus this so we can see a little better. Yeah, this is weird. I'm not sure why this one's not working. At least it's failing faster now, right? Let's give it a second here. We may have to do another deployment. And I have not deployed anything in a while. No, failed to test real-time endpoint. Upstream request failed. Details. Let's revert to the second one. Update. Let's go to the one. Uh-oh. Deploy details. Oh, I see. Looks like the provision state is bad. Let's go to deployment logs. Yeah, see, look, it loads up the stuff, right? So it loads the classes, the params. It loads the model with the entry point. Interesting. We just may have to redeploy this model. I think we tried to do the Onyx runtime originally and run this thing in the cloud and right in the browser, but it just with the model was too big, if I remember right. Let's look at this one. Yeah, see, look, you can see some predictions going through. But this was 421. So this was like 2 months ago. So this is what's supposed to return here. So pre-prediction, prediction complete, preparing payload, stopping clock. Yeah, starting it. So this is the process. So it starts the inference clock, loads the image. Bloom. Looks like it predicted rock. It was very, very confident in rock. And that's what it returned. So this is 13866138110. This is the right one. For some reason, there's like a provisioning updated state. Interesting. Interesting. All right, let's do a MIR deploy. Managed inference, Azure ML. Let's fix this. Here we go. Okay, AZ account set. Here we go. So this is the blue. Let's do a Rochambeau endpoint. So let's create a new endpoint. Let's do that. Because this, something's not quite right here. And it might have broken. So let's create, and we're going to do a Rochambeau. I think I had one, but I turned it off because we're going to make this a managed endpoint. Next. Here, we'll use this one. Rochambeau model. Deployment name, default. We'll do this. Let's see what our deployment thing was. Looks like we're using a standard NC6. Let me see how long that took for deployment. So master.ml. Maybe we can give it a beefier machine and a beefier container, and it'll be faster. So let's go to endpoints here. By the way, if you have questions, feel free to just ask me a question. Let me go to deployment logs here. Okay. So it took 1/3 of a second, which is not. This is not super duper, and it's because it's on an NC6. So let's go to browse. Wait, what are we doing? Oh, scoring file and dependencies. So let's go to our C projects. Rochambeau. Boop. And let's go to our AI goodness. And we want the scoring file. Okay. Let's select the environment that we want, because I think we already have the environment that we pre-built it, right? This is PyTorch Lightning GPU Deploy version 3. PyTorch Lightning deploy GPU deploy. Ah, there it is, version 3. Next. Let's use a GPU here. There we go. Looks like the lowest one I could do is standard NC12 v3. Oh. Let's do one. Let's do 2 instance count. Let's do 1 instant. There you go. I mean, I guess that's what we're going to have to do. Next, traffic allocation on default is that. Okay, so let's create this. All right. So for those that are wondering, I'm basically in Azure Machine Learning Studio. I'm redeploying a model that we built eons ago. But because of Azure Machine Learning, I don't have to rebuild the model. I just have to use the ones that I built before, which is nice, right? And so that's happening. And the idea is whenever we send a prediction from here, it should go to there. Let me go over here. Where is the, yeah, so here's some errors. Yes. Oh, the other thing I did, and I don't like this. Maybe we'll undo that. Maybe we'll undo that. I like Azure Static Web Apps, but they're so hard to debug. So if I could find a way, because I know Next has a way of having built-in APIs. Yeah, there it is. Post image. This is it. Yeah, see. If I could. Oh wow, look at this. I think we tried to do it in here and it didn't work. Okay. So let's find out from Next.js. Sorry, I need to talk to my mic. Oh, what is going on here? It's like you can do routes directly in Next.js. In fact, I think I did that in another project. So github.com. Seth, what is auto form? Yeah, I think I did it here. So let's go to pages. Yep, API, analyze.ts. So I think you just have to, in the pages directory, put an API. So let's do that. So web pages. Oh, there it is. What the heck? I already have this in here. Delete. I'm just going to copy the one I have over here. API, analyze.ts. I'm just going to copy this. Boom. Because I know this one works. So let's go to close. We might be able to get rid of the API thing. So new, I think, and analyze. I think I don't want this. This I don't need. I don't need any of this. So we'll take that out. Oh, rest error. So maybe we do want that. So let's delete this. Let's stop what you're doing here. So I don't need this. I don't need this. And then we'll just say result equals. Oh, thank you. Thank you. Oh, sorry. Const. There you go. And here, rest error. Looks like, what is this? Azure Core HTTP? What is that? What is this? Azure Core HTTP. This is the core HTTP pipeline for Azure SDK, which work browser auto rest, text script. Examples can be found in the samples folder. Cool. So let me copy this and I'll just do a yarn add. This is like cool, like elevator music, I think. Oh, hey. Hey, yo. Boop. So there's some happiness here. And it looks like this is cool. Because in theory, I should be able to now from the index page, because it looks like I'm posting. So that's message, set frame, post, image frame, headers. If canvas.current.image, let me just do this. Okay, so this should take us, wait, what's wrong? Where's the unhappiness? Button. Why are you unhappy? Which attribute? Text. Oh. Or test. Okay. Okay. And I think it's expecting a response. So let me just send it a dummy response that I know works. Oh. Looks like that's completed. But this is the response that we want to give it back. So let me take that and let me return that from analyze. So it's a little more, you know. Boop. Thank you. Okay, so that should return the thing that we expect. And so, okay. So let's do a yarn dev here. And let's go back. See if this little thing works. Okay, here we go. Refresh. There should be a button somewhere, but I don't see it. Oh, it's invisible. And then handle submit. Here it is. Where is this called? Set frame. And then how does this happen? On frame set. Oh, so there's a component that does this. And then the handle submit. On click. So whenever I click on, see, this is hidden too. Okay, let's go see. Let's go see. There you go. So submit should call. What's unhappy now? Oh, this TS config is unhappy. Psh. Psh. We'll get back to you. Not my problem right now. So in theory, we should hit this breakpoint now. So let's try it. Let's try it. Because what I'm doing is I'm moving the API from an Azure function directly into the Next.js app. Because I just, sometimes you just got to cut your losses. Okay, so let's hit submit. Okay. So there was no breakpoint here. Oh, that's because I didn't start it with the. Okay, that's because I didn't start it with the debugger. So let's see if we can figure out how to start with a debugger. So let me go to this thing. Let me go to this thing here. So I want to close this, close this, close this, close this. Here. So let's go to AutoForm, and maybe there's like a launch.json. Yes. 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 This. Psh. Workspace folder web. Okay. Okay. So in theory, oh, what is this? Oh, yes, I remember. I used to have a workspace thing. Psh. Psh, psh, psh. I don't need the Azure functions anymore. In fact, this code is all I need. Looks like I used Axios as well. Honestly, like I'm just gonna move this over here and just delete this whole folder, because why the heck not? So we'll take this and we'll move it over here. And this whole thing can just go away. Delete. Oh man, deleting things is so nice. Hello, Yasser. By the way, what we're doing right now is we're trying to build an interactive rock, paper, scissors thing. I haven't looked at it in a while, and so right now we're in the process of cleaning things up, basically. So I don't think I need to use Axios. This I don't need to use here. Yeah, I'll need to fix this later. I think I guess I can use Axios, but I'll just add it. Yarn add Axios. Because this is actually the actual analyze code, right? And then this is literally the call. I'll just comment it out. Index. Okay. Yeah, that's good. Well, I mean, let me just comment this out. Is there like a way to comment stuff in comment? How do you comment all of it? I'll just I'll just leave this alone for a second because we still just need to get this to work. Okay. Because I need to get the request, right? And that's something I don't know how to do. I think here, yeah, see, this just gets the image. Okay. Okay. Maybe I don't know how this does it with, I know how this does it with Azure Functions. I don't know how this does it here. So let's, in theory, we should be able now to debug this. And I should be able to put a breakpoint here. Oh, there's already a breakpoint. There's a breakpoint there. Let's see if we can make it, you know, breakpoint. Okay. So refresh here. Over constrained. That's right. Submit. Okay, we hit a breakpoint. Fantastic. So let's take a look at the request here. Okay, I have to. Okay, let's go to debug console and let's take a look at the request object. Is there like a body in here? Let's see, request.client. Like, how do I get the, is it body? No. I got to find out how to, so cookies, headers, method, preview data, query, nothing in the query, raw headers, raw trailers, socket, URL. Okay. Let's take a look at our code here. And let's take a look at the source. How did we actually pull stuff out? It just passed the request in? What the heck is that? Okay. Let me just type in REQ, incoming message. Okay. I'm not seeing. Well, we're just going to have to ask. We're going to have to ask. So let's see here. Next API request. Go to definition. Query the values, cookie. It's just like I look at the body, right? There should be a body object. Request.body. And it says it's undefined. Preview data. Okay. Okay, so Avi, it's going to send this result and it's going to look nice. So it gets there. Oh, it's going to stop again. So F5 here, real quick. Why does it not like this? Okay, let's go back over here. Looks like we're at least. So this button is not needed. This button's not needed. I think if I do this, it should be happy. But I don't understand why it doesn't like this. Let's try it again. Refresher. Boop. So the result is just this. Oh, maybe it just needs to be this. It's going to error, but that's okay. Sorry, I pushed the wrong thing. It's going to error, but that's okay because I think I'm just returning the wrong thing. So let's go back over here. Refresh. Submit. Oh, whoops. Oh, that's why. Derf. Let me take this off. Let's sort out the sending. Yeah, see, now it's happy. So this is good. Jeez, stop. Yeah, dumb. Take that off. Okay. So now we're sending the thing and we're getting the right thing back. Okay. But now what we need to do is we need to figure out oh, by the way, let's see if this I didn't is this still deploying? Yeah, it's still deploying. It's okay. I figured that would take a little bit of time. So we don't need this. We don't need this. This we've figured out. That's still going. Okay. Go. So now all we need to do is figure out why we're not setting the right frame. Because it should be in here. So if we go to the index, the frame set should be here. I wonder if we're getting it. Dad, why is this so... Wrong mouse. I have two mices. Okay, so that's different now. Okay, so this is the image that we're sending, which is great. So this is the right thing. In fact, if I copy this and then base 64 to image. Base 64 to image. Let me make sure it's going to be wrong because it's going to have these things in there. 1, 2. Yeah. So look, it's... Wait, why is it the wrong size? Oh wow, yeah, that could cause issues when we're doing the holy cow, this is really bad because this could cause issues. So it looks like we got a couple of issues. One, it's the image. One, it's the image that's being sent is not right, and then the other is we're not getting the image. So let's go back and let's sort out the one that I think is easier. Let's submit something here. Did it not? Oh, I took the breakpoint off like So let's stop. Let's restart. Because this request should have that image inside of it. Because I know it's getting, I think it's getting sent. Yeah, that's fine. There should be something in the body here. So something's not getting sent over, right? Shh, don't care about that. So this should send the right thing. I don't know why. Hold on, let's do this. I know how we can look at this. Let me unstuck this. Let's go to network. Let's delete everything and let's hit submit. Yeah, so we're sending this payload. Oh shoot, why is it not? Oh, it's breakpointing. Okay, so I took that breakpoint off, so I need to do this whole request again. That way it's not just... So... Okay, so here's the whole thing. Here's the header. The request is a post. The request header should have, yeah, application JSON. Here's the request payload. That's what we're sending. This is the response, which is great. So why am I not getting the... So it's sending the right thing. I'm just not getting it in the request. Why is that? There's like no body. Undefined. Let's see. Ask. Let's ask. Oh man, that's it. That's it. I have this goofy thing in here. And that was from a previous thing. So I need to stop. Okay, I think this will fix it. At least for getting the body. So let's hit that. Okay. Let's get this. Yeah, the image gets dropped to 16 by 9, which is probably going to hose our prediction, which is not cool. So I need to figure out how to fix that crap because that will break. Like, it will predict all sorts of goofy things. Unless I put my thing in front of my face, which maybe that's what the computer wanted all along, you know? That's what the computer wanted all along. It wanted me to cover my face. Computer. It's probably sentient. It knows that it doesn't like my face. It's like, cover your face with paper every time, Seth. Okay, let's go back. So let's refresh here. Let's go to this one. Submit. And now I should be able to request a body. Oh. There it is. That's exactly what I want. Sweet. Sweet. So that works now. So we just need to const image equals body dot data dot image, and I think that will do it. Oh, sorry, request. Let's see what this looks like. If I do this, what? Request.body image. I don't need all this rigmarole. Okay, and then when I send stuff, when I sent it before in the index. Oh snap! I can literally just send it. This is gonna break, obviously, because I don't have the. What is this? Index and index everywhere. What is this? Stop trying to be helpful. Yeah, this is almost the same. In fact, I probably. Is that what it was? Oh, stink. Request.body. Yeah, I honestly just need to send it the request.body. I don't need this. I can just say request.body because it's exactly the same. Request.body. And then these are the headers. But obviously we need to wait until we get the key and the thing, you know. So we'll stop this for now. This is wrong. Okay. Okay. So that's the first problem. Okay. The second problem is this image is not the right size. Yeah, I know. That's because I stopped it. Or did I? Okay. All right, let's go over here to see if this is done. Oh, it's done deploying. So let's test it. Oh, see, that's in there now. Good. So this works. So this is fast and it works. But it says it thinks it's paper. The freak. And a garbage model is this. Rock, paper, and then So this model is bad too. Jeez. Copy. Huh. So we have all sorts of issues with this. Let me add another deployment to this. Manage next. We're going to let's use the Roxy model 34 because it's the same style model. We'll call this Roxy. Oh, here's an NC6. Oh, no. Too much quota. No. Okay, what do I need to turn off? Compute. So that stopped. Clusters. Gandalf. Oh, wow. I have an NC24 V3. How about them apples? So I think I need to turn off some other things. I think I should. Well, I know this one doesn't work, so I'm just going to kill it. Delete. Delete. Am I not playing this? Stop. Stop. Oh, shoot. What's going on here? Everything's broken. Everything doesn't work. It's all broken. Die. Okay. I think I confused it. I wonder if I use parcel instead of Webpack. I don't know. Nice. Okay. So that's still deleting. I think we can just point it at this thing and then my keys. I have to refresh my keys. Regenerate. Regenerate. Okay, they're all regenerated now. So I also need to add some secrets to this project. So I'll just stop it for now. And looks like I need to add them to the environment file. Is there a .env? Is that what we're doing here? .env, yeah. Jeez, RNV, what is the matter with you, buddy? Okay. And it looks like I need this equals. I need this. And I'm going to add them without you looking because ain't nobody got time for that. Okay, so let me move it over here. Inference endpoint. Copy. Beep, 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 beep. Copy the key. Copy the key. We close that file and we never speak of it again. Never. Let me put this back over here. Okay. Maybe I need to not have an NC12. Although it was fast. Did you notice how fast it was? Oh no, it's the same speed. No, it's a little it's like marginally faster. Marginally faster. I know so much dust on it. I know. So much dust. Oh, jeez. Holy cow, we only have 20 minutes. Okay, we're gonna get this working again in 20 minutes. Okay. So now we have these. In theory, I should be able to do this. Let's see what we did here. No, this is the wrong place. Response.data is what we did. Response.data. So body is response. And then this, my good sir, can go away. Okay. So it's doing actual predictions now, in theory. So let's F5 this. And then we'll need to see about fixing our model. Oh, no, then we need to fix our picture size. Picture size, and then our model. Okay. Okay, here we go. Here you are. Let's look at our network request because we're going to start to see it go somewhere else. Submit. Okay. So that one actually went to the server. Let's make it like completely obvious. Again, it's going to get clipped, so just I need to. All right, so these are actual predictions. Actual predictions, which is nice. So we've got something going here. But now what we need to do is we need to fix the model. The model needs to be rebuilt. The model needs to be rebuilt. You know what I can do is I can cheat and just like build it locally and upload it instead of going through the entire, process. Okay. All right, let's see if it even sees paper. Yeah. Yeah, it's just going to be a problem for it. It's going to be a problem for it for two reasons. One, because this image is wrong, right? Base 64 to image. One, two. Yeah, see, I mean, it's not even the right size. Like, what the heck is going on? So we need to figure that out too. So let's figure that out next. Oh, well. I think there's a way for me to fix the model, but by cheating. Is it still deleting? Gosh, hurry up. Let's see if I can add a deployment here. We're going to use the Roxy model, which is newer. We'll call it Roxy. Oh, cool. So that works. And then we'll switch to traffic. Okay. So that model should be better. I mean, if Roxy is better. We'll test that one in a second. Okay, so we're deploying a different model into that endpoint. The good news is that the key and the URI is the same, so it's not going to matter. Okay. Cool. Now we need to figure out what's going on with the image clipping. Yes. So we don't need this anymore. It's going to the actual endpoint, which is fantastico. We should probably get some error checking on the client side. This, we don't need you anymore. Go away. Goodbye. Here. 320 by 240. Handle submit. It's happening here. So it's here that's this is doing something. Okay. Okay. So, here it is. And that's kind of what I'm... Oh, this is so tiny. I'm so sorry. This is kind of what I'm doing. It's kind of what I'm doing. Let's take a look. However, this I'm not doing. Okay. Canvas dot height equals video dot current video height. Okay. Canvas dot width. Thank you. We got the context of the canvas. Then this seems to be not useful. Canvas width, canvas height. Okay. Canvas width. And then I'm sending the data URL because I don't need to set this. Okay, so this This should be more right. Well, let's check on our other pan and let's check on our other pan. Where are you? Where are you? Show me the goodness. Not this. We can close this. There we go. Oh, done. So let's refresh here. Now it's reallocating the traffic right now. Oh shoot! It's still deploying. Hold on. It's still updating, so it's not healthy yet. Okay. Cross our fingers on that one. Okay, so submit. Let's copy this here. Oh, nice. That is the right size. Okay. Right now it thinks it's paper though, because the model sucks. Okay, so that actually is right. Nice. We can take, so there was something wrong with what I was doing. It just wasn't okay. It just wasn't okay. So that's better. Let's go back to this. I don't need to log this anymore. I don't need to log this anymore because ain't nobody got time for that. We'll log the predictions because that's still good. Okay. Okay. And then let's just go over here and refresh. Is it just not gonna? Oh, jeez. Oh, jeez. Scissors, it has a problem with. Rock. Popper. Oops. Do I have a none? This is going to throw an error, maybe. Oh, it didn't. Oh, it did. Yeah, so there was an error message, but it still repeated the right thing. And I identified, yeah, cool. Ding, ding, ding. So we fixed the image thing. I'm hoping that this endpoint will get updated. But let's go to deployment logs. There's no deployment logs for it. Maybe it's just taking a while because there's no errors so far. We don't need this one either. Let's delete this one. Yeah, see, that's an NC12E3. It's sucking up stuff. I don't even know what this does. I don't know what it does. Goodbye. Goodbye. I know what this does. We're going to leave that one for a little bit. Yeah, scissors gives paper at least. So we're going through and solving problems that I think we've had the whole time. So, okay. So the deployment completed. Let's see if it's in a good... Yeah, it looks like it's in a good state. Let's refresh it. Oh, maybe it's not in a good state. Deployment logs. There you go. Okay. So this is using a ResNet 18, which should... Oh, now it's... Okay, cool. Now it's redoing the traffic allocation. So maybe this is it. Maybe this is going to be the good model. Maybe this is going to be the good predictions, and we're going to actually fix some things. Next time, I'm going to have to fix some of the deployments. Okay. So let's refresh here. Looks like there you go. So let's test it. Yeah, see that one, this one's much better. So now if I go to this thing, in theory, oh, what? We did it. Hold on. Let's see what else here. So submit. Yes. Hoo-yah! None. Oh. Yes. So we've got some things working there, thank goodness. So a couple of things that we did is, this is great. This is great. So we basically undid the GitHub action. So I'm gonna have to refix this. I'm gonna have to fix some of these workflows. I'll fix them offline. That way it deploys, because I have to redirect my URL and stuff. What I'll do is I'll set that up so that the CI/CD process is great next time. So yeah, we'll do that. And then what we also did is, it turns out that there was a bug in that we were sending a 16:9 image, which was going to clearly mess things up. Now I think it's pretty good. I mean, you can see it's pretty good. I mean, 71 it's not bad. So it's actually really smart now, because I'm using a better model. But a couple of things we need to do. We need to update the CI/CD of the website. We need to start integrating a full cycle MLOps thing, so that anytime it makes a mistake, it saves the image somewhere, and then it can put it into the MLOps. So every week we'll train it or something. Because eventually what I want to do is I want to make sure everyone can create their own account, and then make a model specific to, it'll use the base model to start training, and then refine with y'all's images. That way you can play against it, and then I'll build an AI that knows how to play against you. It'll learn how to play against you, and then eventually, hopefully, we can do it so people can just show up, a la chat roulette, and just start play rock paper scissors, 3, 2, 1, boop, and then it freezes it. Something like that, because that would be fun, I think. Oh shoot, we are got to start playing the walk-off music here. So that's what we did. And the other thing we did is, I don't think you saw that. Well, you did, but we actually redeployed our model. And I didn't do any. I just did it all in the. I did it in the UI, right? Because it's my wonderful friends. Next week we have. Let's see if I can get this showing. A deep dive into the latest from the Responsible AI dashboard and scorecard with myself and a couple of friends, Mernouche and maybe Minsu, are going to come and help us with that. But yeah, I mean, this is pretty cool. I feel a lot better about this. I'm going to check some of this stuff in. I'm going to fix some of the workflows here so that the Azure, that way it's, doing the right thing. We deleted a lot of stuff, which is awesome. Looks like I need to ignore the env. And let's check it in. Well, no, the GitHub action is going to run, and so we're pissed. So we don't need this SWA CLI config anymore. Delete. What is this? Helper. Yes. We did it. This was awesome. Yeah. I feel so much better about this, having it all in one project. I just need to deploy this. I know how to deploy it. I'm going to use just a standard web app that we'll deploy to, and I'll reroute the UI so that it's all good. And this is cool. This is much better than we had. So now I don't think I need. I'm going to take this out because I don't want this. Tasks. No, we don't need this. These were all like. I think just the launch is good enough for me. And then extensions, I don't need this. We're not using them anymore. We will need to fix this workflow for static websites, which is fine. And then this is our training. This is our training thing. This has been amazing. Y'all are the best. Thank you so much for showing up. Again, in 2 weeks, we're going to be back with Minsu and or Manoush to talk about the responsible AI stuff. It's been a privilege and a pleasure being with each and every one of you. If you have any questions, make sure to reach out to me on the Twitter. I'm happy to answer any questions. Thank you so much for watching, and hopefully we'll see you next time. Take care.